Hello students, welcome to the topic differentiability. In this video, I am going to discuss a very important theorem on derivative. There are two important theorems in differential calculus. One is Rolle's theorem and another one is mean value theorem. In this video, I am going to discuss about the Rolle's theorem. What is the statement in geometrical interpretation and examples on Rolle's theorem. Now let's see what is a statement of the theorem. So Rolle's theorem states that let f from closed interval a comma b to r be a real valued function and f is continuous on closed interval a comma b and differentiable on open interval a comma b such that f of a is equal to f of b, then there exists some point C belongs to open interval a comma b such that f dash of C is equal to 0. So the meaning is, if f is continuous on closed interval a comma b and differentiable on open interval a comma b such that this condition, that is f of a and f of b, the function value of the first endpoint and function value of the endpoint, if these two are equal, then there exists in between a and b number, okay, excluding a and b, in between a and b number there exists a one point, that is a one number, such that derivative value at c, that means derivative value always it gives you 0 number. So that is the statement of the theorem. If f is continuous on closed interval ab and differentiable on ab such that function values of endpoints, that is f of a and f of b, are equal, then in between a and b there exists a point, and at that point derivative value always you will get a 0 meaning. So this is the statement of the theorem. Now see geometrical significance of Rolle's theorem. So consider coordinate axis. Let me draw a curve y is equal to f of x. So consider this is a f of x graph and 2 points on the x-axis, that is a. With respect to a, this is a function value f of a. Therefore, the point on the curve is f of a, and b point on x-axis, and this is a point on the curve f of b point it is. Now these two are equal, means we get a straight line. If these two are equal, then what happens, there exists a point C on x-axis, that is a in between a and b, there exists a point C such that at C point on the curve, if you draw a tangent, remember the tangent is parallel to x-axis. So this is the Rolle's theorem states, in between if f of a and f of b are equal, then there exists a point C such that at C point to the curve, if you draw tangent, the tangent is parallel to x-axis. Now what is the slope of this tangent? Slope is parallel to x-axis, therefore slope of this tangent line is nothing but 0 value. So in the statement given that f dash of c is 0, and here we have tangent slope is 0, so which means that derivative of the function at c is nothing but slope of the tangent. So this is a geometrical meaning of Rolle's theorem. So that means if f of a and f of b are equal, then definitely in between these 2 points, the curve at any one point, it will bend. That is the meaning. So geometrically, it means that if f of a is equal to f of b, then there exists a c in open interval ab such that slope of the tangent at c. Here you can see that a tangent is drawn and its slope is 0. Slope of the tangent at c is 0. That is f dash of c value is 0. That is the meaning. Which means that f dash of c is nothing but slope of the tangent at c point. So therefore, geometrical meaning of derivative is nothing but slope of the tangent. You have to remember this statement, students. That is, if f of a equal to f of b, then there exists a point c in open interval a comma b such that the tangent at c is parallel to x-axis. So getting a tangent slope is 0 is nothing but parallel to x-axis only. And from this, you have to remember slope of the tangent meaning is f dash of x, that is dy by dx. This is in general slope of the tangent at any point. This is derivative at any point, dy by dx. Now let me discuss some important points. Remember the following points. Rolle's theorem is applied for the function if the following conditions are satisfied. The first point is if f of x is continuous in closed interval a comma b. Second point is if f of x is differentiable in open interval ab. And the third point is if f of a is equal to f of b. If these three conditions are satisfied, then we get a point C in open interval a comma b. Now remember these points also. The Rolle's theorem cannot be applied to the function if the function is not continuous, that is discontinuous in the closed interval a comma b, or the function is not differentiable in the open interval a comma b, or if f of a is not equal to f of b. Students, if any one of these conditions not satisfied, then Rolle's theorem cannot be applied. Now let me solve the problems. Verify Rolle's theorem for the function f of x is equal to x square plus 2x minus 8. X is belongs to minus 4 comma 2. This is the closed interval minus 4 comma 2. This is a point and this is b point. Now we have to verify the Rolle's theorem. That means the point exists or not, that we have to check it. Now first let me discuss about the 3 points. First is continuous, second one is differentiable or not, the third one is f of a is equal to f of b. So always for the example or for the function, we have to check these 3 points to verify the Rolle's theorem. So let me first take a given function is f of x is equal to x square plus 2x minus 8. Now let me discuss about the continuity. So in continuity topic, you studied that polynomial function is always continuous function. So therefore given function is polynomial in x. Here you can say that x square plus 2x minus 8. So this function is polynomial function. So therefore it is continuous in all the points. So therefore it is continuous in the closed interval minus 4 comma 2. So always you have to write the first step about the continuity and differentiability of the function. So since a given function f of x is polynomial function, so first point is function is continuous in closed interval minus 4 comma 2. And second point is differentiable in minus 4 comma 2. And third is we have to check f of a and f of b numbers are equal or not. Therefore, let me operate first f of a number, that is minus 4. F of minus 4 means in this f of x, put x equal to minus 4. So it become minus 4 whole square plus 2 into minus 4 and minus 8. So in the next step, simplify this one, you will get 16 minus 8 minus 8. So that is f of minus 4 is 0 value, and denote this as a f of a. In the same way, you operate f of b number, that is f of 2 number. 2 square plus 2 into 2 minus 8. So this is equal to, so 2 square means 4, 2 into 2 is 4 minus 8. So here f of 2 is 0, and take this as a f of b. Now here you can see that f of a value is also 0, f of b is also 0. So right here f of a is equal to f of b, that is f of minus 4 is equal to f of 2. Now f dash of x is equal to, okay, because Rolle's theorem f dash of c point, so therefore find out the f dash of x means function derivative x square plus 2x minus 8. So differentiating f of x with respect to x, you will get 2x plus 2. By Rolle's theorem, we have f dash of c is equal to 0. So f dash of c means in f dash function, replace x by c number. That is a 2c plus 2 is equal to 0, because f dash of x is 2x. So here it is a 2c plus 2. Simplify this and get the c point. So transfer 2 right side, you will get 2c is equal to minus 2. It becomes plus 2 to minus 2. And 2 again transfer to right side, that is 2 is a product to the c point, therefore it goes to denominator of minus 2, that is minus 2 divided by 2, and here it cancel, so therefore you will get minus 1. Now the point is, this point is belongs to the open interval or not. So minus 1 definitely it is belongs to minus 4 comma 2. So this number in between the interval or given points it exists, which means that at this point minus 1, if you draw a tangent, the tangent is parallel to x-axis. So at this point the tangent is parallel to x-axis. Remember students. Now second example. Verify Rolle's theorem for the function f of x is equal to x square plus 2 and x is belongs to minus 2 comma 2. So first given function, you take f of x equal to x square plus 2. Now x square plus 2 is also a polynomial function, so therefore you write it since given f of x is a polynomial function, first point is f of x is continuous in closed interval minus 2 comma 2, and second point is f of x is differentiable in open interval minus 2 comma 2, and find out the function values. F of minus 2 equal to minus 2 square plus 2, so it becomes 4 plus 2, that is f of minus 2 value is 6. Denote this as a f of a. In the same way, operate f of 2, it is 2 square plus 2, so that is 4 plus 2. So f of 2 you will get 6. and denote this as f of b. So here you can see that both are equal. So therefore write here f of a equal to f of b, that is f of minus 2 equal to f of 2. So after that you find out derivative of the given f of x, that is f dash of x. It is x square plus 2 function. So x square derivative is 2x and 2 is a constant, its value is 0. So therefore f dash of x is only 2x. So now by Rolle's theorem, we have f dash of c is equal to 0 condition. So take that one and find out the point. So f dash of c equal to 0, that is a 2c is equal to 0. So here so many students they write x only. So if you write x, it is a general point, variable it is. So be careful students, here you write 2c. In f dash of x function, replace x by c number. Okay, that is 2c equal to 0. So 2 if you transfer, you will get a 0 divided by 2, which is nothing but 0 only. And this 0 is belongs to the interval minus 2 comma 2. So which means that at 0 point to the curve, if you draw tangent, the tangent is parallel to x-axis. That is the meaning. Now see the next question. Examine the Rolle's theorem for the function f of x is equal to greatest integer x. X is belongs to 5 comma 9. Now first take given function f of x is greatest integer function. Now let me discuss first the continuity of the function. So in continuity topic you learned that the greatest integer function is discontinuous at every integer number. Once again I repeat, the greatest integer function is discontinuous, that is not continuous, at every integer number. Okay, so we know that the greatest integer function is discontinuous, that is not continuous at all the integer points. So here the given function f of x, that is greatest integer function, and x is in between closed interval 5 comma 9. So here in this interval we have many integer numbers. So therefore this greatest integer function is discontinuous at that point. So as I said in the important points, function should be continuous in the closed interval. So therefore here we got discontinuity. So therefore what we can say, Rolle's theorem fails. So x is belongs to closed interval 5 comma 9 is discontinuous at the points 5, 6, 7, 8 and 9, because these are the integers in between closed interval 5 comma 9. So therefore what we can say, Rolle's theorem fails. Now see the next example. Examine the Rolle's theorem for the function f of x is equal to mod x. X is belongs to closed interval minus 1 comma 1. So now we are discussing about the modulus function. So first take given function f of x equal to mod x. Now let me discuss first continuity of this modulus function. So in continuity topic you studied that modulus function is continuous for all the real numbers. Therefore it is continuous in the closed interval minus 1 to 1. So write that one. We know that modulus function is continuous for all the real numbers. Therefore f of x is equal to mod x is continuous in closed interval minus 1 comma 1. But modulus function is not differentiable at the point 0. Okay, so this one you proved that in continuity topic, modulus function is not differentiable at 0 point, and that 0 point lies in open interval minus 1 comma 1. Okay. So therefore what we can say here, modulus is not differentiable in the given interval. But modulus x is not differentiable at x equal to 0 and 0 belongs to open interval minus 1 comma 1. So therefore what we can say here, modulus function is not differentiable in open interval minus 1 comma 1. So therefore Rolle's theorems fail. Now see the next example. Examine the Rolle's theorem for the function f of x is equal to x square minus 1 and x is belongs to closed interval 1 comma 2. First take given function, let f of x equal to x square minus 1. Now this is polynomial function, so clearly it is a continuous. Since given function f of x is polynomial function, f of x is continuous in closed interval 1 comma 2, and second point is f of x is differentiable in open interval 1 comma 2. Now check the equality f of a and f of b, that is f of 1 and f of 2, whether they are equal or not. So therefore you operate f of 1, that is in this f function put x equal to 1, 1 square minus 1, so which is 1 minus 1, nothing but 0 value, denote this as a f of a. And second f of 2, 2 square minus 1, and that is 4 minus 1, that is f of 2 value is 3. This is f of b. So here you can see that f of 2 is 3, f of 1 is a 0, they are different, therefore f of a not equal to f of b, that is f of 1 is not equal to f of 2, therefore Rolle's theorem fails. That means we cannot apply Rolle's theorem here. I hope you understood, students. Thank you, students.